specifications where you want the class to be called.
So questions? PA5, Lab 5.
Just want to make sure you got this right. You wanted us to create a server socket, and then they create a normal socket that tries to connect to, if it's on two computers, how does the socket connect to the server socket?
Yeah, that's a good question.
I think you've explained this to me 2 times now.
That's okay.
I just...
It's the trick is hearing an explanation when your mind is at the point where it can take it in.
And hearing it in different ways.
Yeah, yeah. So here's the server. We'll put the server on the left today. Here's the client. So you make a server socket. And you give it a port number. And the server has its own IP address, right? That's a function of the machine itself. The server socket has a port number that's an artifact of the socket that you're creating.
Yeah.
The client has an IP address, but that doesn't really come into play. So the client creates a socket, and when you construct, you specify 2 things. You specify the IP address of the server and the port number of the server socket.
Okay, so you just
And then when the server says accept, it'll create a new socket which will be connected to the client socket. So you only need to know the IP address of the server.
Oh, yeah, that's a good point. You just ask a computer which computer you're trying to connect to.
Yeah, yeah.
And that's how it usually works. Okay. So how does server socket return a socket?
Server socket returns a server socket, but then, so this is SS equals, but then when you say accept, this returns a socket.
Oh, okay.
And that gets connected to.
Okay. So you accept after you find a connection?
You create the server socket, which listens for connections, and you say accept. This will block until somebody comes in and says, I want to connect to that server socket. And this will return with a socket that's connected to the socket that connected to the server socket.
And then
It's
if
a
you
lot of
wanted
socket.
multiple people going in, how did you do that again?
So once you get a connection, this unblocks, right? It returns. So instead of going into a loop that does back and forth communication, right? Throw that into a new thread and go back and accept another connection.
So because the threads are separate, if let's say you were doing let's say you're doing PA5 and you're doing the text chat thing. What if you wanted to do it kind of like how Facebook Messenger sets it up, where you've got the different conversations with different people? So let's say you're on client side, you want to speak to somebody that's in a different client.
Okay.
How would you
So you could
go about setting that sort of thing up?
You could just have, when you return from this loop or whatever, you just create maybe a new window, or like there's a card system you can do, so you use a new card. And you could just remember which socket is returning a new socket each time, and you're just like switching sockets to talk to different people. How would you know when SS accept? Does that wait for a connection? Okay.
Yeah, it blocks until the connection request comes in.
Okay.
So on the server side, you know everything, right? You know every time that somebody makes a connection request, and you get a socket connected to that, and you can just throw it off in the thread and forget about it, but you can also throw it into some kind of data structure. And you can build up a structure over here on the server side that says this client's talking to this socket, that client's talking to that socket, and so on. And so you can do things like have a big communal chat. So every time a client sends something to the corresponding thread, right, that can get communicated back to the original process over here, which could send it out to every socket that's connected. And then you've got kind of an IRC thing where one person types and everybody sees. And you can have identities associated with these, and you can put those in as prefixes, and you can do pretty much anything you want, right? Because on the server side, you know all of this.
I was just a little distracted. So if you have the one socket that S is accepted, you have that in a loop, that returns a different socket each time, right?
Mm-hmm. Yep.
So if you have to send out, you would have to like have it send through each socket to send through all of
Mm-hmm.
them, right?
Yeah.
Okay.
And if you take those sockets and you just throw them in a linked list or something,
Yeah.
a list array, right, you can iterate through and
Okay.
broadcast to everybody. So other questions? Anyone gotten Lab 5 done?
Pretty much.
Pretty much?
Just need to find someone
Do it?
to, just need to find someone to test it with.
Ah, okay.
Or to finish it.
So you can connect these pies together with just regular jumper wires, but there's some longer wire in that cabinet where the boxes are. There should be some gray Cat5 cable, and you can get big wires out of there. But if you want longer wires to do a more intense test, let me know. You only need 3 wires. Technically, you can use a 3-pronged extension cord, because those are big, beefy wires. Just use alligator clips or something, but don't plug it into the wall. You blow up your pie.
And for PA5,
Mm-hmm.
it's one server and one client, right?
Yeah,
Just one way to click that comes.
Yeah, the essential goal is run the server. Okay, that's sitting there doing nothing. Run the client. It establishes a connection. You can type on the client, the server sees it. You can type on the server, the client sees it. And you can type at any time. You don't have to wait for the other person to hit enter, for example. And then the client can exit, and another client can come in, connect to the server, and now you've got a new conversation. Right? But at any given time, only one conversation going on. That's the essential requirement.
So we don't need to use threads or anything.
You don't, well, you will need to use threads for one thing.
When receiving it has to print out.
Yeah, yeah.
Okay.
But you don't need to
Use
put
the
that whole
whole,
thing
yeah.
in a separate thread, so you can do
Okay.
multiple, no. But you can if you're bored. Have nothing to do.
So, when you're making a server socket,
Mm-hmm.
it says it could throw an exception. Why would that throw an exception
If you try to get to a port that you can't connect to,
with the server socket?
yeah, so you specify a port that you want to bind the server
Oh,
side
okay,
to.
If you try to do a port that doesn't exist.
If you do a port that doesn't exist, or a port that's in use, or a port below 1024 that you don't have privileges for,
Okay.
I don't know if there's other things that might. Does anybody here remember a time when Windows did not have networking automatically built in? You had to install a TCP/IP stack. It's hard to believe that was not that long ago. But it's kind of cool that it's always there. So I was just going to run real quickly through my code for PA4 because a few people asked. And this is not particularly well-written code. I actually wrote this a long time ago. and it made life a lot harder than I needed to. For example, putting a Boolean in to tell you whether it's a question or not. Well, you can tell whether a node is a question or an answer because if it's got children, it's a question. If it has no children, it's an answer. But I was young. But anyway, here's a version of 20 questions. So string database, right, reads from particular file, and this is the only place you have to change what the name of the file is. So this is used for both reading and writing, right, as opposed to having multiple things you need to change. So that's the path to the file that has the database. And the main method basically constructs a decision tree out of the database. So the tree constructor takes a string, right, of a path, ingests from it, returns a decision tree, and then print out a hello message, and then here's the whole loop for playing the game. So this runs forever, play a game, and then save the tree back to the file, and just loop forever. Right, so it's a pretty concise main program. And so all the hard stuff happens inside play a game. So play a game, you hand it this decision tree. It does the dialogue with the user, takes you to the end of the tree, prints out what it thinks you're thinking of, and if you're wrong, has that extra dialogue, and then updates the tree. And then traverse database, I just always write back into the file from the tree, whether it changed or not. We could have returned a Boolean here to say if the tree got updated, and then said if play a game, then traverse, etc. So how do you play a game? I did all this weird stuff with like the previous node and the next node, so I did the current and trailing pointer as I went through the tree, so that when I got to a leaf, I knew who the parent was, and I adjusted their child instead of just updating the child in place. That gives you more variables, but it works. So usual standard in reader. I threw in a one-time init if you don't have anything in the input file, so that it's an empty decision tree. It'll call one-time init, which just hardwires our basic tree. So is it an animal, yes or no? But that wasn't required for this assignment. So temporary pointing at the root, instructions, think of an object, I'll try to guess what it is. And as long as the current node is a question, I print out that question itself with a question mark at the end. I get a new line from the user, and I pick off the first character, and if it starts with a Y, it's going to be a yes. If it starts off with an N, it'll be a no. So next line, I'm taking character at 0. Why am I concatenating a space on next line?
If it's empty, you might not have anything to read.
If it's empty, the character at 0 will throw an exception. It'll say invalid argument 0. So this makes sure that I have at least one character in here, and if I already had a character, the space on the end isn't going to change anything because I'm just looking at the first character.
They just press enter with the character at 0 to return the new line character?
I don't think it has a new line, but I'm not positive.
Okay.
So this loop is just making sure they actually say Y or N. So if it's not Y and it's not N, then I remind them to say Y or N, and I repeat the question and I get another answer. And so that just makes sure they do clean input. You can throw that into a method, right? Get answer, and the answer can just do this and return a Y or an N or a Boolean or whatever you like. So they've answered Y or N, so if the answer is Y, then I set temp equal to the yes branch, otherwise I set it to the no branch. And this just plays down from here to here until you get to a leaf. And when you're at a leaf, you say, okay, I've got it. Is it A? And you print out the text from that node, which is going to be an answer. And then I get the user's response, and again, I force them to answer either a Y or an N. If they say Y, then I got it, thanks for playing, and I return. That's the end of the decision tree playing. Otherwise, tell them that you stumped me, ask what they were thinking of, that's the final answer. tell me a yes/no question for which yes means the final answer, okay, the correct answer, and no means the incorrect answer that I guessed. So they get a new question, that's new queue, and then this is all just doing the node assignments to make a new node, store the new question there. Yes node is the final answer, no node is the no answer. And this is just deciding whether to put it on the left or the right of the previous node. Like I say, you don't have to do that. You can just replace the node that you were at, the leaf node. But I didn't do that for some reason. And that's the end of the whole play the game. That's the one-time init. And then the tree code is straightforward tree stuff we've done before, other than the ingest. So to ingest a file name, right, we construct a scanner off of that. A few people miss this. They try to construct a scanner directly with the path name. That doesn't work. You can construct a scanner with system.in. You can construct it with a file, but not with a string. So you have to take the string, use that to construct a file, and then use that file to construct the scanner. It doesn't complain when you do this, but it doesn't actually read from the file if you just put in the name here. So let's see, open a scanner on that. And I expect the file to begin with a question, so I'm double checking that in case you have a totally gibberish file. That will probably catch it. So read a question, set the yes branch to read tree, set the no branch to read tree. And read tree is just the recursion that we talked about. So if there's no next line, we hit the end of the file. That should never happen. That's a problem with the file. Otherwise, read the next line. If it's an answer, take the next line, make that the text, make the yes and no branches null and return. Otherwise, set the text equal to the next line, and then recursively read to set the left and right yes and no branches and return. So that's that ingest algorithm that we talked about a few times. And then traversal, we call the roots traverse method. And the roots traverse is just the usual pre-order traversal. So print out the data with a Q or A in front of it, followed by a colon, followed by the actual text, and then traverse the yes and no branches if they're not null. So that works. So to test your code, I started with the 3-node tree, right? Is it an animal, yes or no? And I played through that, made sure it played, and then is it an animal, yes? Is it a pig, no? So I put in a dog with a question, does it bark? And then played through that. And then, is it an animal? No. Is it a rock? No. It's a pillow. Is it soft? Put that in, played through that, made sure it played the tree, and then exited your program if it wasn't exiting automatically, reran it, made sure it read that new file correctly, and still worked down all 4 of those different pathways. And then I had a slightly longer file with applesauce and Kirby in it, and played through that 3 or 4 iterations, and then I sticked it on the big 20-question one just to make sure nothing kind of pathological was going on. And if you answer 4 yeses, 4 nos, and 2 yeses, it brings you down to a dog. So that was another test case. And then I eyeballed your code and looked for general coding style, anything glaring that jumped out at me, things like that. So that was the basic methodology.
So can you put your code up in the canvas too?
I'd rather not.
Okay.
Only because you can find this online, right? So I got this assignment idea from someone at UW, right? Because he offered me the big database file, and I was like, cool. And a few years ago, I had a submission from a student and it looked suspicious. And I started Googling some lines of text. Well, I found the code online. And it was actually from the class at UW. Somebody had posted their code, and this person found a copy of it and just put their name on it and turned it in. So, I'd rather not contribute to the body of easily accessible. Right. But you can find the one that somebody posted pretty easily. And if you want to come by and look at it and go through comparisons, we can do that. All right, let's see. So we haven't really talked about jar files yet, right? Okay. So this is some catch-up stuff with a C, not a K. Jar files. So if you're in Eclipse, everything's kind of like handled for you, right? You create a bunch of classes and they're all accessible and you just hit the run button and it runs. But if you're sitting at a command line, right, or if you're trying to implement something like what Eclipse has implemented for you, things are a little more complicated. So I've got some Java code here. I've got a main method, which is well, I've got a circle class, okay, which constructs a circle, and it constructs with a radius, and it has an area method. It's an integer circle. I've got a main method, which will construct a rectangle and a circle and print out their areas, and I've got a rectangle class, which, you know, constructs a rectangle with height and width and returns the area. And that's all I've got in this directory right now, 3.java files. I can compile my main method with Java-C, and that should give me a main.class. But if I look in here, I've also got a circle.class and a rect.class now. Because inside main.java, it knows that I'm trying to use this class called circle, and it looks in the current directory and it doesn't see a circle.class, but it does see a circle.java. So it compiles that. And that's important because if the only thing I compiled was main.java into main.class, and then I tried to run main, it's going to complain that it can't find a class rect. So the .java, right, those are source files. That's your code. The .class is the compiled version. It's the bytecode. And when you try to run a program, right, when you say Java main, it's trying to run the static method big main dot little main, and that's going to try to construct some objects of type rectangle and circle, and the only way it knows how to do that is to find the class files. And it's going to look in the current directory, but if it doesn't find them, it will complain. So we can recompile to create those. We've got the class files now, and now when we try to run main, it works fine. So this all works pretty painlessly if you're sitting in one directory. You put all your .java files, you compile your main program, everything else gets compiled automatically. It's kind of like a makefile built in for you. But it gets more challenging if all you've got is your main program and these classes that you're trying to use are sitting somewhere else. So for example, right now these are sitting in a subdirectory called good. And if I say compile main.java, I'm back to my compile errors because it doesn't know about rectangle and circle. So it would be nice if there was a way to tell Java where it can find these class files so that we don't have to move them into this current directory. So this is something called a class path. We're working up the jar files. This is something called a class path, and by default your class path is your current directory. That's where it looks for classes that are missing. But you can specify dash class path, or dash CP is a shortcut, space, and then a colon separated list of directories, and then your usual rest of your line. So it's a switch which lets you specify where to look for classes. So I can say compile with a class path of good, in other words, look in that directory, and compile main.java. And that will successfully compile it into main.class. But again, if I try to run it just by saying Java main, it doesn't know where rectangle is. So I can say java-class path good and tell it, hey, look in the good directory for my classes. But now it doesn't know where to find the main class, because I said look in good and main isn't inside good. So here you need to specify both current directory and subdirectory good, and now it runs successfully. So this is still not too painful, right? And you never type these things in more than once or twice. You throw them in a script or an alias, or you use your command recall a lot. But imagine that you've got, hundreds of classes, maybe sitting in a bunch of different directories, because you're using something that was provided to you, something you downloaded, some sort of interface or API. And these lines can get really long, right? And sometimes that's okay. Sometimes you just live with it and you go ahead and you put them in a script. But it's not ideal. So this is the idea of a jar file. It's a way to take a bunch of class files and sort of group them into a single file. And it's really just a zip file, but it's called a jar file, okay, a Java archive. So AR is the Linux archive command. Takes a bunch of files, puts them into a single one. So what is tar?
Would it be tar archive, maybe?
What's the T stand for? Take a guess.
Text.
Close, good guess.
Temporary?
Good guess also. Go back to the 60s.
Tape.
Tape. That's a tape archive. So jar, that's a Java archive. Different parts of speech, that's okay, it's Linux. So jar works very much like tar. So you can say jar, create verbose file, name of the jar file, and then the things you want to put into the jar, typically class files. If you would?
You run a jar file as an executable for it works.
Yes, yes. So let's go into good. I've got two class files. So I'm going to say jar create verbose file, my jar.jar, and we'll just put our class files in there. So it tells me I'm adding two class files. It also says added manifest. It adds some metadata into this. So I can say jar tvf to do a table of contents on my jar.jar, and it shows me the contents. There's two. There's a manifest file in a subdirectory, and then there's my two classes. So I can copy my jar.jar into my directory. So now I've got my main program it got compiled to main.class, and there's a jar file. And I'm going to get rid of this good directory. And let's start from scratch. We've got my main program.java, and we've got a jar file. So now I can say java c class path myjar.jar. And we'll compile main.java. So that compiles. And then to run it, I can say class path dot colon myjar.jar, and it'll execute fine. So jar files are useful, right, for your own stuff. If you're making large projects, it's useful to bundle them into a jar file. And in Eclipse, you can also make executable jar files. So you can take an Eclipse project and, well, let's just go ahead and do that. Let's make sure this runs. Okay. None of this is relevant. I just need a different workspace because my workspace is too cluttered. So I'm just going to move my tic-tac-toe to a different workspace. My uncluttered workspaces are getting cluttered too. This should work. Alright, so import existing project into workspace. Okay, so I'm going to right click this, I'm going to say export, and I'm going to come down here to Java, and I'm going to say runnable jar file. And I'll pick a destination. I'll just call it T3 on my desktop. And then you have to go to launch configuration and put in the name. Oh boy, I got a mess. We'll take one shot. Tell me if you see T3. I don't know. Where's my main class? T3. Well, if you do what I suggested in the beginning and you don't put all your projects into one workspace, then you should pretty easily see your main method here, and you can export that. but I didn't do that, so this isn't gonna work. But anyway, export this, and then you can run it by just saying java-jar in the name of the jar file. Or if it's in Windows, you can just click on it, and it will go ahead and execute it. I don't think that's it. Yeah. All right. Well, that's a fail. But anyway, so when you want to run this, just java-jar filename.jar. And it'll go ahead and run it. You don't need to be any clips. And if you've got swing and you've got widgets and stuff, that all works automatically. But I gotta clean up my workspace to show that. So, just as kind of a example of this, I wanted to get my computer talking a while ago because I was running stuff in the background. I didn't want to keep checking to see if something had happened, so I wanted to just sort of like talk so it would get my attention if I needed to look at something. So, there's speech synthesis modules available, and they come to you as a jar file, right? And this is how a lot of code is distributed for Java. So you've heard of APIs, right? So this is an application programming interface. An API is really, mostly it's just a set of function calls, right? It's documentation. It says how you do different things with whatever the system is. So here's a method for initializing, here's a method for setting up these things, here's how you deinitialize and exit, and so on and so forth. And along with that documentation, there's usually one or more jar files that contain all of the classes that are being described in the API. So this was a speech synthesis module, came in as one jar file, and a lot of this stuff, I have no idea what it does. Okay, it's boilerplate stuff that you get from the documentation. But there's a synthesizer mode description, there's an actual synthesizer, and there's a voice. So the synthesizer is the machinery that creates the tones that you hear as a voice. The voice is a way to code information about a particular voice, the pitch, the cadence, and so on and so forth. And the mode description, I have no idea what that is. So you have an initialize method which takes the name of a voice, and it basically searches through a built-in database of voices looking for an entry that matches that name, and if it finds it, it will use the information from that to set the tone and the pitch and the cadence and so on and so forth. But I didn't write this, right? This was in the documentation, and you put it in verbatim, and it works. So I can say I want to use Kevin 16, and it will loop through the voices looking for something that matches that name, and then store that in this voice object. And then set the voice on the synthesizer accordingly, right? And it's all objects. It's all, you know, a synthesizer's an object. You can get a synthesizer properties from here, and you can use that to get to a set voice method. Terminate just shuts down the synthesizer, so you call it the allocate method. And then doSpeak takes a string and uses the speak plain text method on the synthesizer, and then does a wait until the transmit queue is empty. It's spoken everything because it's going to take, you know, several seconds to say something. So it waits until all of the things you asked it to speak have been emptied out from the queue. And then here's the fantastic code I actually wrote myself, right? So construct a synthesizer unit SU, call the init method with the name Kevin16. So that was a quote high quality voice. And then call the doSpeak method, and I just pass it a string. And it should recite that out loud, and then I call the terminate method. to shut it down. So when I unpack the jar file, right, there's a .project directory. That doesn't tell me what I need. There's a class path directory. So this is where it dropped the jar file. Right, it's a pretty big file because it's got like dictionaries inside, but it's a jar file. So that's all the stuff that's in it. Right, so a few classes. Right, and each of these is a .java file somewhere. Now I don't have the source code for this. I think it's open source, but I didn't download the source code, right? But whoever wrote this wrote the Java files, compiled them, stuck them all into the jar file. And there's different paths in here, right? There's stuff under the subdirectory com_sun speech free TTS util. There's com_sun speech free TTS RELP and so on. And these are all things that you can grab either explicitly by using dot notation, or you can say import, and it'll look for things that begin with whatever you put in the import line, right? So this is a hierarchy of libraries, basically packages, for all these different classes. So I can compile by specifying a class path of my current directory and that jar file. And then I can execute by saying Java, and again put in the full class path.
This is a test.
And there you go.
Attention. Long dialog detected. Please check the chemical maps.
Right, and so that's the statement I asked it to read at the bottom there. So now you've got a speech capability, right? And anything that you can do with a print line, you can call to your synthesizer .dospeak, and it'll say it for you now. Right? And you do that setup stuff, you do that, you know, put it somewhere up in the beginning, so I put it in an init method, and now we've just got a nice way to like make our system talk. And this is typical of things that you'll download and use, right? I bought at Best Buy this very inexpensive little infrared device. It sits on your desktop, plugs into a USB, and it monitors the environment around it. And if you put your hand near it, it detects where your hand is, what orientation it's in, where your 5 fingers are. Are they bent or extended? Are they closed or open? And so on. And it makes all that information available through an API. So you can you know, read that raw information and do things with it, but you can also teach it about gestures. So if you make a fist like this, you can have it trigger a callback and run a piece of code and do something, right? And somebody did all that hard work of the engineering of the physical device and the translating of what it receives. It's infrared, so it just sort of scans the environment, translating that into, you know, this physical interpretation, and it's just available to you. As, you know, you can call a method and get a Boolean, is my hand closed or open, stuff like that. And it's a big world out there, right? There's so much stuff, and a lot of it has Java APIs available. Sometimes it's Python, sometimes it's C, usually not C anymore. Sometimes it's through sockets. There's a brainwave scanner that somebody was doing an SLP on. You put it on your head and you talks wirelessly to a dongle that goes in your USB port. And there's an API you can use for that, but you can also set it up to just stream information to a socket. And you can connect to that socket through, you know, whatever your favorite method is, anything like what we've been doing, and just start pulling in sort of raw brainwave data, and then do what you like with that. So this really kind of gets you out of the box, right? we can write code for so long where we're just sort of like doing things in our laptop, but eventually you want to sort of go beyond that, and these are different ways that you can make that happen. So keep an eye out when you're looking at gizmos and toys, right? Look for these abilities because they're fun to take advantage of. All right, so questions, comments?
And where did you download the source from?
Oh, I don't know. I Googled. I really don't know because I found a lot of stuff, and it actually took a fair amount of effort, you know, like a half hour, of lots of different tries before it worked because I didn't know what I was doing. And, you know, if you read the documentation, it's more easy, but I'd never read documentation. So I was just kind of like trying to compile stuff, and it was complaining that I couldn't find this class or that class. And then I just started pulling down jar files and untarring them and putting them through grep and looking for the class I wanted. And then when I found one, I tried that, and it worked. So I don't know what I'm doing. But that's half the fun of it, right? If you like puzzle solving, there's lots of ways to do that. But if you like, you know, knowing what you're doing, you can always find documentation and follow it from there. All right, so tomorrow I'm going to really briefly go through a bit of Android development with Android Studio, just to get you to the point where you can press a button and have it display some text or something like that. So I'll bring in an old cell phone running Android, and we'll fire up Android Studio and go start to finish. Just to let you see, because it's another application of Java, and it looks and feels a fair amount like Window Builder and Swing. It's totally different, but it's the same kind of user experience, dragging and dropping and connecting actions to code and so on and so forth. So we'll play around with that tomorrow, and then Thursday we'll probably talk about some C++. And then next week, Monday, we'll do PA5 demonstrations, and then we'll probably finish up C++ after that and do some review, and then it's done. All right, cool. I will see you next time.